The debate over whether light is a particle or a wave goes back many centuries. In the 17th century, Isaac Newton believed that light is made of a stream of tiny moving particles, using the fact that light travels and reflects in straight lines, indicative of discrete objects. However, other prominent physicists of the era, such as Christian Huygens, disputed this idea. Huygens thought that light is a wave phenomenon, citing the diffracting and partial refracting of light, which were things that the particle theory could not explain. So who is right? The answer turns out to be both, although neither had the full picture. Modern experiments have provided evidence for what we call the wave-particle duality of light. While light does behave as a wave, the wave is not fully continuous. It can be broken up into tiny indivisible packets of energy, which act like particles. Today we call those little packets photons. Thus, light exhibits both particle and wave properties. So if light acts as both wave and particle, might other things act the same way? In 1924, French physicist Louis de Broglie hypothesized that matter could also behave as waves. This theory was confirmed a few years later when researchers observed electrons, previously thought to be discrete particles, diffracting. These de Broglie matter waves have a wavelength given by Planck's constant over the momentum of the object, its mass times its velocity. Planck's constant is astronomically small in our everyday units. This explains why something more massive, like say, a penguin, does not display any wave behavior. With such a large mass, even a small velocity renders the wavelength far too small for us to detect. Nevertheless, wave-particle duality is still considered to be one of the greatest ever discoveries in quantum mechanics, and even physics in general.